Alright, let's do minimum operations to make binary array elements equal to 1. Alright, you're given a binary array nums. You can do the following operation on the array any number of times, possibly 0. Choose any 3 consecutive elements from the array and flip all of them. Choose any 3 consecutive elements. And you can do this operation on the array any number of times. Okay, so at any given time, choose, you have to do a flip. So it's not optional to flip, but you can do it multiple times in different spots maybe. Flipping an element means changing its value from 0 to 1 to 0. Return the minimum number of operations required to make all the elements of the numbers equal to 1. If it's possible, return -1. Okay. So, for example here, you flip these 3, it's all zeros. No, you're flipping it to equal to 1. So you probably need to flip these. So that's 1. You flip these, that's 2. And then at that point, these are all zeros. So you flip those, and that's all 1s. So there's 3 operations here. And then you can't do this one. Okay, this seems pretty straightforward. I think you can just try a greedy approach here. I don't see why, like, you flip these, that becomes 1, and then these become 0, so you have to flip these, and then that becomes 1s. So you flip these, it becomes, I probably should just explain this. 0, 1, 1, 0, 0. Yeah, I think you just try a greedy approach here. So whenever you see a 0, you know you have to flip it to a 1, so you just flip the next 3. And then in the end case, if it's not possible, it's not possible. There's just no way that you don't flip any zeros. Okay. So I'll say here this can be, I'll try a greedy approach first. Greedy approach means you don't really worry about consequences later on, maybe side effects or maybe things that might go wrong. You just at all times do the optimal thing for that one situation and see if it leads you to the optimal answer. Some things don't work that way, like traveling salesman problem, you can't do it. But so at any bit that is 0, flip that and next 2 bits. One operation. Basically perform the operation. And then see number of operations and whether it works at the end. Alright, go ahead and try this out. So, say the answer is starting with 0. For let's say n is the number of values here, length of nums, and then for each value, or for each index in nums in range of n, let's say b1 is equal to nums at this index. This is going to go out of bounds because I'm going to go b2 and b3. If b1 is equal to 0, then you flip it. So answer plus equals 1. Nums at this index is now equal to 1. and then nums at index plus 1 is equal to 1 minus it. That's just a quick way of doing the flip. And then nums at index plus 2 is equal to 1 minus nums at index of 1, index plus 2. And I think that's fine. Okay, I'm just going to go out of bounds, so I go n minus 2. N minus 0 is for the 1 value, n minus 2, n minus 1 is for 2 values, n minus 2 is for 3 values. Okay. I guess I really just could say if nums at index. Alright. And then at the very end, it really just depends on whether or not the last two values are correctly ones, because we can't really do any more flips. So return if the nums at the last value is 1 and the nums at the second to last value is also 1. Oh, sorry. They want the number of operations. So if this is true, they're all flipped, then return the answer, else return -1. Okay. Pretty straightforward. Is there a faster way of doing this? Answer is originally 0. Just go through it. Let's do this more quickly. I don't know if you can do more quickly. Well, maybe you can. Maybe you can. Do you actually need to flip them all? Do you need to flip them all? So, is it possible to look at something and determine that it just would work? So here, the 1 flips to, this thing flips to 1, these flip to zeros. And then here, this thing flips to this thing becomes a 0. So then this thing flips to a 1, and this thing flips to a 1, and this thing flips to a 0. I wonder if there's some like formula here that can calculate to do this sort of modular thing. This almost feels like a math problem. Where you can answer it. So if you have 0, 1, 1, 1, that doesn't work. But if you had extra zeros, yeah, there's probably some sort of formula here, some quick arithmetic besides flipping values. If it's a 0, if you see a 0, Interesting, interesting. So at any given index, if you see a 0, then you need to do a flip. And that requires currently 3 operations, or really 4 operations if you do the tracking of it. So one operation to get the answer is required to track it. That there has to be something there. That's required. The question is, can you consolidate these 3 into something? All right. Well, you don't really need to set the number at this index to 1. You know that you're going to do that anyway. So you just need to flip those other 2. I mean, that might be a 33% improvement there. Okay, maybe it's not as big as a 33% improvement. Okay, so you flip the current number, and then you know that you need to flip the next 2 numbers. You know that you need to change the next 2 numbers. So when you see a 0, if you just know that the next 2 are going to be opposites, it's like almost like unraveling a tied knot. It's like you're unraveling a tied knot because you're flipping it so many times. Flip this, flip this. You see this, flip it some more. See a 0 here, then you flip these 2. So this is 0, you flip flip that to 1, these 2 to 0. This is 0, you flip these 2 to become, at that point, 1, 0. You see that's fine, you see this 0, you flip these 2 to be 1s, all 1s. And you say for any given 3, at any given point, if you need to do a flip, then the number of subsequent flips that you have to do depends on this and depends on this. So this becomes 1, and these 2 become 0s. I don't know if this is worth trying to optimize something that's already at 85%. 1, 0, 0, 1, 1, 0, 1, 1, 1. There has to be some sort of math formula for this. Like, what would the math formula be? So if you see 1s, then you don't need to increase it. So if you have a bunch of 1s, so there's nothing here. If you see 0, like how many more flips do you need? You see a 0, you make that into a 1, and these become the negation. One, and these becomes negative. And then you see another, and then you see another, when you negate something, it doesn't really matter if it's a 0 or 1, I think. Well, no, it does. If you negate a 0, then you don't have to do any more operations. So you do need to count the number of operations immediately after it. So negate it, you look at the next one, you negate it, you look at the next one, but looking at the next one, why would you want to use an if statement? I mean, you're going to eventually use an if statement at the next one too. So you negate it, so 0, you negate it, there has to be something here. 1, 0, 0. Following 2 zeros have to change. Now technically if there's 2 zeros falling change, then this one we need to flip once, and then this thing is flipped with it. So if the following thing, you have 2 falling zeros, then you really only need to clear one operation to clear both. But if it's something like 1, if it was 0, 1, 0, 0, 1, 0, then it flips to become 0. It would flip to become 1, 0, 1. And then you flip the second one to become 1, 0, whatever. Interesting. So if you have a 1 followed by a 0, then the third one is going to get flipped. But if you have a 1 followed by a 1, then you don't need to worry about, well, the 1 followed by a 0, 1 followed by a 0, and the third one isn't 0, then you just need to flip it twice. And then you could move on to the next set. Yeah, whatever. This is stupid. I'm not gonna try to optimize this further. Summary algorithm. Yeah, that's this summary there. Greedy approach. Just try to fix the current set of 3. Time complexity, this is going to be O of n. You're going to go through each index in your array, your size of array is n. So go through all indices of array, do constant for each. And to place convexity, this is going to be simply O of 1. Just have some constant variables. Usage. Alright, cool beans. Too easy.